To find information on busbar spacing, consider several resources. Firstly, industry standards such as the Institute of Electrical and Electronics Engineers Standard 605-2022 and the National Electrical Code Section 430 provide relevant guidelines. Secondly, manufacturers' recommendations from companies like Eaton, Siemens, and Schneider Electric offer specific specifications for their busway product. Thirdly, articles and technical papers, such as those discussing busbar spacing as a critical factor in high-power electronics and optimal busbar spacing for high-power electronic systems, give valuable insights. Additionally, resources like design considerations for busbars can be helpful. Fourthly, online calculators, including the busbar spacing calculator from Emerson and the busbar spacing calculator from ABB, can assist in determining appropriate spacing. It is important to consider the current carrying capacity of the busbars. Adequate ventilation should be provided to prevent overheating. Busbars should be kept away from flammable materials. For specific guidance, it is advisable to consult with an experienced electrician or engineer. Busbar systems are a critical component in electrical power distribution, serving as the backbone for carrying large currents within electrical switchboards, substations, and other power equipment. Proper busbar spacing is essential for the safe and efficient operation of these systems, and several factors must be considered to ensure optimal performance. One of the primary considerations in busbar spacing is the current carrying capacity of the busbars themselves. The amount of current a busbar can safely carry is determined by its material, cross-sectional area, and the ambient temperature. Exceeding the current carrying capacity can lead to overheating, which can damage the busbar, surrounding equipment, and potentially cause a fire. Therefore, it is crucial to select busbars with an appropriate current carrying capacity for the intended application and to ensure that the spacing allows for adequate heat dissipation. The Institute of Electrical and Electronics Engineers Standard 605.2022 and the National Electrical Code Section 430 offer guidance on determining the appropriate current carrying capacity for busbars based on their material and size. Ventilation plays a vital role in preventing overheating of busbars. Adequate ventilation allows for the removal of heat generated by the busbars due to resistive losses. Insufficient ventilation can lead to a buildup of heat, increasing the busbar temperature and potentially reducing its current carrying capacity. The spacing between busbars should be sufficient to allow for adequate airflow around the busbars. The specific ventilation requirements will depend on the current carrying capacity of the busbars, the ambient temperature, and the presence of other heat-generating equipment in the vicinity. Manufacturers' recommendations for busway products, such as those from Eaton, Siemens, and Schneider Electric, typically include guidelines on ventilation requirements. Keeping busbars away from flammable materials is essential for preventing fires. Busbars can reach high temperatures under heavy loads, and if they come into contact with flammable materials, such as insulation or plastic, they can ignite a fire. The spacing between busbars and flammable material should be sufficient to prevent accidental contact. It is also important to ensure that the area around the busbars is kept clean and free of debris. Articles and technical papers, such as those discussing busbar spacing as a critical factor in high-power electronics, can provide additional insights into fire safety considerations. In addition to current carrying capacity, ventilation, and fire safety, other factors to consider in busbar spacing include voltage levels, short-circuit currents, and insulation requirements. Higher voltage levels require greater spacing between busbars to prevent electrical arcing. Short-circuit currents can generate significant electromagnetic forces that can cause busbars to move or deform. The spacing between busbars should be sufficient to withstand these forces. Insulation is used to prevent accidental contact with energized busbars and to protect against environmental factors such as moisture and dust. The type of insulation used will depend on the voltage level, environmental conditions, and the specific application. Online calculators, such as the busbar spacing calculator from Emerson and the busbar spacing calculator from ABB, can assist in determining appropriate spacing based on these factors. When designing busbar systems, it is important to consult with an experienced electrician or engineer. An experienced professional can assess the specific requirements of the application and provide guidance on selecting the appropriate busbars, spacing, and installation. They can also ensure that the busbar system complies with all applicable codes and standards. In summary, proper busbar spacing is crucial for the safe and efficient operation of electrical power distribution systems. Several factors must be considered, including current carrying capacity, ventilation, fire safety, voltage levels, short-circuit currents, and insulation requirements. Consulting with an experienced electrician or engineer is essential for ensuring that the busbar system is properly designed and installed. Busbar systems are integral to modern electrical infrastructure, facilitating the reliable and efficient transfer of electrical power. Understanding the nuances of busbar spacing is paramount for engineers, electricians, and technicians involved in the design, installation, and maintenance of electrical systems. The spacing between busbars is not merely an arbitrary dimension, but a carefully calculated parameter that directly impacts the performance, safety, and longevity of the entire electrical system. Firstly, the current carrying capacity of busbars is a fundamental consideration in determining the appropriate spacing. Busbars are designed to conduct electrical current, and the amount of current they can safely carry is limited by their material properties, cross-sectional area, and the surrounding environment. When current flows through a busbar, it generates heat due to resistive losses. This heat must be dissipated to prevent the busbar from overheating, which can lead to reduced performance, insulation breakdown, and even catastrophic failure. The spacing between busbars plays a crucial role in heat dissipation. Adequate spacing allows for natural convection and radiation, enabling the heat generated by the busbars to be effectively transferred to the surrounding air. Conversely, insufficient spacing restricts airflow and impedes heat dissipation, leading to elevated busbar temperatures. Secondly, ventilation is intrinsically linked to busbar spacing and heat management. Proper ventilation ensures a continuous flow of air around the busbars, facilitating the removal of heat and maintaining a stable operating temperature. The design of the busbar system should incorporate features that promote adequate ventilation, such as strategically placed vents or fans. The spacing between busbars should be sufficient to allow for unimpeded airflow, preventing the formation of stagnant air pockets that can trap heat. The ambient temperature of the environment in which the busbars are installed also plays a significant role in ventilation requirements. In hotter environments, more aggressive ventilation strategies may be necessary to maintain acceptable busbar temperatures. Thirdly, fire safety is a paramount concern in electrical systems, and busbar spacing is a critical factor in mitigating fire hazards. Busbars operate at high voltages and currents, and any electrical fault or insulation breakdown can generate intense heat and potentially ignite nearby flammable materials. The spacing between busbars and flammable material should be sufficient to prevent accidental contact and minimize the risk of fire. Furthermore, the materials used in the construction of the busbar system should be fire-resistant or non-combustible to further enhance safety. Regular inspections and maintenance are essential to identify and address any potential fire hazards, such as damaged insulation or loose connections. Fourthly, voltage levels directly influence the required spacing between busbars. Higher voltage levels necessitate greater spacing to prevent electrical arcing, which is the formation of a conductive path through the air between two conductors. Electrical arcing can cause significant damage to equipment, disrupt power flow, and pose a serious safety hazard. The spacing between busbars must be sufficient to withstand the electrical stress imposed by the voltage difference, preventing the initiation of an arc. The dielectric strength of the air, which is its ability to resist electrical breakdown, is a key factor in determining the required spacing. Factors such as humidity and altitude can affect the dielectric strength of air and should be taken into consideration. Fifthly, short-circuit currents represent a significant threat to the integrity of busbar systems. When a short circuit occurs, a large surge of current flows through the busbars, generating substantial electromagnetic forces. These forces can cause the busbars to move, deform, or even rupture, leading to equipment damage and potential safety hazards. The spacing between busbars should be sufficient to withstand the electromagnetic forces generated during a short-circuit event. The design of the busbar system should incorporate features that enhance its mechanical strength and stability, such as robust supports and bracing. Short-circuit calculations are essential to determine the magnitude of the forces that the busbars will be subjected to, allowing for appropriate spacing and structural reinforcement. Sixthly, insulation plays a vital role in preventing accidental contact with energized busbars and protecting against environmental factors. Insulation is a non-conductive material that surrounds the busbars, providing a barrier against electrical shock and preventing the ingress of moisture, dust, and other contaminants. The type of insulation used depends on the voltage level, environmental conditions, and the specific application. The spacing between busbars should be sufficient to accommodate the insulation thickness, ensuring that there is adequate electrical clearance. Regular inspections of the insulation are essential to identify and address any signs of damage or degradation. Seventhly, industry standards and regulatory codes provide guidance on busbar spacing requirements. Organizations such as the Institute of Electrical and Electronics Engineers and the National Electrical Code develop and maintain standards that address various aspects of electrical safety and performance, including busbar spacing. These standards are based on extensive research and testing and represent best practices for ensuring the safe and reliable operation of electrical systems. Compliance with industry standards and regulatory codes is essential for minimizing risks and ensuring that the busbar system meets all applicable requirements. Eighthly, manufacturers' recommendations offer valuable insights into the specific spacing requirements for their busbar product. Manufacturers conduct extensive testing and analysis to determine the optimal spacing for their products, taking into account factors such as current carrying capacity, ventilation, and voltage levels. Following manufacturers' recommendations is crucial for ensuring that the busbar system performs as intended and meets all safety requirements. Deviation from manufacturers' recommendations can void warranties and increase the risk of equipment failure. Ninthly, online calculators can be useful tools for estimating busbar spacing requirements. These calculators typically take into account factors such as current carrying capacity, voltage levels, and ambient temperature to provide an estimated spacing value. However, it is important to note that online calculators should not be used as a substitute for professional engineering judgment. The results of online calculators should be carefully reviewed and validated by an experienced engineer to ensure that they are appropriate for the specific application. Tenthly, consulting with an experienced electrician or engineer is essential for ensuring that the busbar system is properly designed and installed. An experienced professional can assess the specific requirements of the application, taking into account all relevant factors, and provide guidance on selecting the appropriate busbars, spacing, and insulation. They can also ensure that the busbar system complies with all applicable codes and standards and is installed in a safe and workmanlike manner. In conclusion, busbar spacing is a critical parameter in electrical power distribution systems that directly impacts performance, safety, and longevity. A multitude of factors must be considered, including current carrying capacity, ventilation, fire safety, voltage levels, short-circuit currents, insulation requirements, industry standards, manufacturers' recommendations, and professional engineering judgment. By carefully considering these factors and consulting with experienced professionals, it is possible to design and install busbar systems that provide reliable and safe electrical power distribution.